Hi there, and welcome to A-Level Maths with me, Elmini Wilson. I do believe today is a good day for you to understand maths better. Let's tackle analytical geometry, or maybe like a synonym. You can also call it coordinate geometry, specifically looking at circles, because circles is the new syllabus, the 2020 syllabus. They introduced circles as a new topic. I also think that what you need for today would be a smart calculator. I prefer the FX991ZA+2. Will help us with a few of the steps, especially completing the square. And then, like I always say, a good state of mind, positive state of mind, quiet environment, stationary, formula sheet. Let's dive into this. We're starting with coordinate geometry. Maybe you did this in your previous levels of maths, where you had to do distance formula, midpoint formula, gradient formula. Just a quick recap. Distance formula, unfortunately, not on your formula sheet. It looks like this, where you do need two coordinates. And when you have two coordinates, you sub them in here and you have your distance. Okay. Midpoint, prefer capital M, would be your two coordinate, your two x's added together, your two y's added together, divide by 2. There's also like a type of reverse midpoint. If you want to deconstruct it, you can say that the midpoint of x and the midpoint of y is equal to x1 plus x2. This is excellent if you maybe have the midpoint, but you're looking for one of the outer points. Okay, again, none of these are on the formula sheet. Then the gradient formula, very important, delta y over delta x, or change in y over change in x. Do you see with all of these, we've got two coordinates. So if I, for instance, give you a set of coordinates, sometimes there's even 3 or 4 coordinates, you give them names. Like let's say you have this scenario, don't get confused. Call this one x1, x2, y1, y2, until you're comfortable with just subbing them into whichever formula. This is basically like the breakdown of everything that you'll need. Maybe just one more, the new syllabus requires us to also know the circle formula. So this is circle. Please notice that with your circle, your A and your B will be your center, and obviously your R will be your radius. So this will be center of the circle, and then you have your X and Y can be any coordinate on your circle. Okay, then I just need to make sure some concepts are, you're familiar with things like perpendicular. Perpendicular is like this, exactly 90. Parallel. When you have parallel lines, remember they've got equal gradients. Parallel lines, train tracks, equal gradients. Also remember a flat line has got a 0 gradient. A line like this, perfectly vertical, has got an undefined gradient. I normally try and explain it like when you're cycling. This is a flat road, right? But this is impossible. So 0 gradient, 0 slope, and then this is an undefined slope. Also, if you want to use perpendicular, you've got the one's gradient. Let's say the one's gradient was 2 over 3, and then you've got a line that's perpendicular to that. You flip it and you change the sign. So maybe that's another formula you can quickly write down. For things that are perpendicular, please remember M1 times M2 equals -1. So if you have like a line that has a gradient of 2 over 3, and you times that with the inverse reciprocal opposite sign, you will get to -1. If you want to see that in a little picture, here's your one gradient, 2 over 3. If you know that it's perpendicular, then it's also equal to -3 over 2 for the other line. By the way, while we are talking about lines, maybe we should just quickly talk about some other types of lines that they love asking. And that will be a perpendicular bisector. Let's say this is A and this is B. So you don't only just cut perpendicularly, you bisect. So you cut in half. If you want steps for perpendicular bisector, remember most of the time they will give you the coordinates of A and B. First step, get the midpoint then of A and B. Remember we spoke about midpoint earlier? This would be the midpoint. You take x1 plus x2 over 2, y1 plus y2 over 2. And then when you have that, you've got the midpoint, which is great because then you at least have a coordinate that's on your perpendicular bisector. So step 1, find midpoint. Step 2 would be find the gradient of AB. Because once you have the gradient of AB, step 3 would be to do this. Flip the gradient, change the sign, and then you've got the gradient. So if I can write that down for you, you'll say 1 over gradient of AB. And then the fourth step will obviously be use y equals mx plus c. Because if I ask you for the perpendicular bisector, I am asking you for the equation of the perpendicular bisector. Okay, so the good news is I know that in your previous levels, there was a lot of geometry that you had to do. But in A levels, we only actually focus on 3 main theorems. But you need to know them very well. You need to know the straightforward version of the theorem, but also the converse. So for instance, if I talk about, let's maybe start with a diameter. If you have a diameter in a circle, do you know that it's always subtended with a 90? That's a very good theorem to remember. But the converse is also true. So if you have a 90, if you proved a triangle has a 90, then this will be the diameter of the circumscribed circle that goes around. And if you have this diameter, then you have the center. So in other words, the converse will also be true. Just remember the 2 theorems. A diameter is always subtended by 90. And if you have a 90, that will always subtend a diameter. Okay, let's go through all 3 theorems. I'm just going to jog through them. The next one, super important. If you have a radius, your radius will always be perpendicular to your tangent. Always, doesn't matter where you are, it can be here. Just make sure that this is a radius, not just a chord. Hey, this is a chord. Maybe we should go through some of the words here. Chord, okay, radius, this is called an arc, this is called a sector, this is called a segment, tangent, okay, so secant, I don't think you need to know much more, center, okay. Also know some other, like a small little theorem is that tangents from the same point are also equal, okay. And also radii, this is not rocket science, you know radii, doesn't matter where I go on my circle, even go here, it will be the same distance. Okay, I know I'm running through them quite fast, but I just want to, this is supposed to be old knowledge and not new knowledge. If I think about the 3rd theorem that you need to know, this one has got so many applications. If you have a center, well, this looks more like an egg. Okay, just pretend like this is nice and round. If you have a center and you've got a chord, and you take a line from your center and you bisect your chord, so that is given, then you need to know that it's perpendicular. Also, the converse could be true. If you know that it's perpendicular, then you know it's bisecting. And then I've got a 3rd thing for you. If you know, let's say you had AB like we had before. If you know that you have a perpendicular bisector of AB, like this was your perpendicular bisector, this line, this perpendicular bisector of the chord has to go through the center. So all of that I just said, very, very important. It's only 3 theorems, so make some space on your wall or where you brush your teeth or your hair, where you can put this up so your eye keeps seeing it constantly, so that when you see a sketch and maybe there's like 2 circles cutting each other, that you will hopefully think of one of these theorems. I did say we're going to mainly focus on circles today. So I want to dive into an immediate equation of a circle. You might argue with me and say this is not a circle, but it is. It's not just not in standard form. If I can remind you what our wish list is, this is standard form. We would love to see it rather be in this form. And to get it there, we will complete the square. Okay, I'll show you the long way, but I would prefer you to obviously do the shortcut. Just for accuracy's sake. First things first, can we just write down all your x's together? And then write down all your y's together. And then all the extras, like any constant, just take it over. Okay, so the long way requires you to do completing the square for x. So I love putting a block there. And completing the square for y as well. the rule says you take half times coefficient of x squared, always. The answer there then is -3, so the final answer is 9. Just see what I do with that. I'm going to pop it in here. I'm going to add 9 to this side, and I'm going to add 9 to that side. Very easy. Okay, same with the y. Half times coefficient of x squared, but in this case, coefficient of y. So that will happen. So then I get 25, almost like a recipe. First time, a few times you make pancakes, it flops, but then after that, it starts getting better and better. So have a look at what I do here. I add 25 to both sides. And then I want to show you the magic of completing the square. Once you've gotten this far, these 3 terms can then become a bracket squared. And inside your bracket, your middle step. So there was method in my madness for writing down all of these steps, okay? The same here, 1, 2, 3 terms. You can combine that into a bracket squared, and that will be on the inside, y plus 5. And then all the goodies on the side there, just add them together. I think I'm going to get 49. Yes. And that is the equation of your circle. So then if I ask you things like, please give me the center or give me the radius, my center is 3 and -5. Notice how my signs are changing. And my radius, remember this is radius squared, so square root of 49 is 7. You can say plus minus 7, but I mean, it doesn't make sense to have a circle with a negative radius. Are you ready for the shortcut? I'm sure you are. This is where our faithful old friend features again. Oh, please don't fall. I'm going to show you some basic steps that I want you to know. Please go out of this mode if you were sketching earlier. I want you to try mode 5-3, because you see number 3 has got square numbers. And then I want you to look at where I am reading. I'm going to only do the x's for now. So type in a 1 and a -6 and a 0 into your calculator right now. A 1 and a -6 and a 0. Okay, so what's going to happen? I'm going to be reading off my answer. I get an answer of x equals 6. So that means this value here needs to be 6. I'm reading at the wrong spot. This is where I should be reading. I fell for my own tricks. Where the first value that I read off is actually my x-intercept. This is my turning point. So I want to see a -3. Remember, the sign will change. So there I want to see a -3. And guess what else I'm going to get? That -9 is obviously going to go over, and it's going to +9 there. So I hope I'm not confusing you. What the calculator gives you is this number and this number. So you need to know how to use it. Let's try it again with the y. Okay. So for the y value, I want you to type in only y's. So 1 and 10 and 0 into mode 5-3. You can type over this 1, 10, 0. Don't fall for that trick again. Don't read that. That's x-intercepts. -5. That means inside my bracket, I want a +5. And then I want to just see the other value. -25, just bring that over, +25. So if you know how to use your calculator, it's actually very useful, because then you know you're not going to make sign errors. Just please don't do what I did. Don't read off the x-intercept. You need to be reading off your turning points. Okay. If we need to move on, obviously completing the square is great, but that's only the start. Getting the center of the circle is sometimes of cardinal importance for other questions. Always a good idea that once you have your circle, to maybe just have a rough sketch of what's happening. Because after this, like I said, they can ask you so many questions. Like, for instance, if I give you a coordinate, let's say 8, 8, how can you tell if this 8, 8 lies outside the circle, or on the circle, or inside the circle? That's a very nice question to ask. And the way we do that is with distance formula. So we get to practice our distance formula that we haven't done today. Just a reminder, this is your distance formula. You subtract your 2x coordinates. Careful, don't get confused with your signs. It's minus on the inside of the brackets and plus in between the brackets. Okay. What I need to do then is I need to compare the distance between my center, which I just found, and my coordinate in question, this 8, 8. If I can find that distance and compare it to the radius's distance, I can then obviously make a judgment call and say, you are bigger, so you are outside. So let's quickly do that. I want to see the distance between x and then that x, don't make sign errors. And then if you chose this one first, you have to choose him again, minus 5. Let's quickly work that out on the calculator. I'll give you a few seconds if you want to try and beat me. Just check your bracket usage. I'm saying that to myself as well. For those of you that might be tempted to just let the squares and the square roots cancel, please get out. You can't do that, now, never in your life. You can't cancel a square and a square root. I always try and explain that because the plus is there, there's no such thing as saying 16 plus 9 is 4 plus 3. That's not true. I just want to make that point because I've seen it so many times happening in past papers that I've marked. So you can't do that. You can't just let the squares and the square roots cancel. I want you to actually get a nice answer from the calculator. Not the nicest answer in the world. I get square root 194. If you SD that, if you press, let me just show you. If you press this button, SD, it will give you the decimal worth. So I get 13.92. Okay. So with the 13.92, I can then compare that to my radius. Yeah, my radius was 7. So just be like, think logically. If this is 7 and this is 13, obviously you're going to lie outside my circle. If you had a distance formula to 8, 8 and you got exactly 7, that means he lies on the circle. And obviously if it was less than 7, it would lie inside the circle. So this is a very typical question that they can ask, inside, outside, on. Sounds like a game. I just want to also make sure that when they ask you a question like this, make sure you show all your steps and some kind of conclusion, like therefore it is outside. Don't just let the examiner make his own conclusions. No, they've got other work to do. You make the conclusion to get full marks. Another type of question that's quite popular, I'm going to use the same circle, is they want the equation of the tangent. If you remember correctly, the tangent is perpendicular to the radius. So very important again, before we can even do that, we need the center. So completing the square, if you can't do that, all of these other questions I'm asking you after is going to fall flat. So please know how to get the center. That's the most important part here. So if I want the equation of a tangent, please remember that a tangent is always perpendicular to the radius. So if I give you the tangential point, let's make it -1. And guys, this is not drawn to scale at all. If I give you -1 and 2 as a point of contact or a tangential point, what do I do to get the equation of the tangent? First thing first, we haven't practiced gradient formula yet today. We do the gradient of the radius. So gradient of rad will be a change in y. So I'm going to choose this one first. 2 minus -5 over, then you have to choose this one first. Don't make sign errors, please. Change in y over change in x. So that's going to be 6 over -4. Just quickly check me. 2, no. Yes. And then that's going to give you -3 over 2. And when you have the gradient of the radius, then immediately you can convert that, flip it around, and then you've got the gradient of the tangent. The reason for that, obviously, in your previous GSC or IGCSE, you had to give me a reason, radius, perpendicular, tangent. I'm not worried about that in AS or A level. You can leave that step out. Just know that that is the reason. So the gradient of my tangent is 2 over 3. And what's so nice is now I have a coordinate as well on my tangent. So I can use y is equal to mx plus c. We were speaking about this earlier. This is the tangent is a straight line. So then you can just sub in your x and your y and your gradient. And that's how I normally find c. I know that there's another formula. Please don't worry if you want to rather use this formula. That's also fine. But then if you do use the second formula, let me just show you. Your coordinate actually goes in here. Your gradient goes in there. And that would be just timesing out distribution, bring that over. I feel like both of them take the same amount of effort. Just don't make sign errors anyway. So if I times this, I'm going to bring it over. I'm going to say 2 plus 2 over 3 is my C value. And remember to write a nice step where you say everything, your gradient and your C value. And that's the equation then of your tangent. Another way where I can ask you something to do with tangents, let me just do this, is if I give you a circle, for instance, and I give you some kind of straight line, and I ask you with a variable, for which values of k will this line be a tangent to the circle? Now, we're normally used to getting y alone, but the best I can do for you is maybe write it in standard form. Maybe that'll be easier to see. So if you look at those two, don't look at the top one. Okay, there's a circle, there's a straight line. You want them to intersect. And then obviously when they intersect, they only intersect once because it's supposed to be a tangent. But how do I even do point of intersection if I can't get y alone? Because see how messy this will be. I can bring things over, but then I have to square root. Even if there were other y values, like let's say I said plus 5y here, it is possible to still do point of intersection by not necessarily setting the equations equal to each other, but subbing the one into the other. If that makes sense, I'm just going to take this away for now. So if you sub the one into the other, it is as good as you are doing point of intersection, set them equal. So that's the problem with circles. You're not going to necessarily get anything alone. So when you want to be solving point of intersection, you sub in. And then I want to remind you, for a tangent, your delta will be equal to naught. So when you analyze your points of intersection, we can actually go a little bit further before I say anything. You can check me. I'm used to having like a live class of people checking me and saying this is wrong, this is wrong. Okay, I just times out my brackets, and then I'm going to add my like terms. Because remember, I'm going to try and analyze my points of intersection. Okay, so remember, descending powers of x is what I do here. To add your x squares together, check that one has an x, that one has an x, but not really like terms. And then that one and that one added together, and then that one at the end. Okay, so if I'd ask you for which values of k, because that was my original question, for which values of k will this line be a tangent to the circle? So I want, obviously the other theorem that you could have used is the fact that there's a 90 there. But if no coordinates are given, you're just given a line and a circle, rather sub it in, go into the point of intersection analysis, which is basically delta, which we're going to do now. Delta is b squared minus 4ac. This comes from your quadratic formula. And remember, if you want a tangent, you want it to cut only once. So you want b squared to 4a minus 4ac to equal naught, to have equal or repeating roots. When you use b, you only use the coefficient of x. So there's a 4 that goes with x, then there's a negative 2k that goes with x. Okay, then minus 4 ac. A would be the coefficient of x squared, and c will be your constant. And then you set it equal to naught. So please remember, there's lots of square brackets here. If you want a shortcut, I just take the square the first, square the last. Don't just do that. That's the worst thing that you can do. Please remember there's a middle term. That times 2. So I'm saying 4 times 2 is 8, times 2 is 16. Yeah, why do I sound unsure? Yes, and then here you can just pretend like this is -8, and then bring the -8 as distribution. -8 times 4 is 32, positive 32. Lots of room for error. Yo, I feel like I'm walking over tripwires. You can check me and laugh at me if this was wrong, but I feel like this is what should be happening. Minus 16k plus 48, and then this is a trinomial. I feel like this is a nice trinomial, but maybe let's just divide everything by 4. Okay, -4, so don't make sign errors, and then you do your 2 brackets. But again, I want to show you, earlier we were doing mode 5.4 on the calculator, actually mode 5.3. Just want to remind you that we can still do that. You go mode 5.3. This is especially designed for trinomials, okay? So we're doing this trinomial. 1 for -12 is what I want you to type in. So let's go for it. 1 for -12. So then my answer is 2. So I can write down here, k is 2. And my other answer, remember, we're not doing turning points now. We're actually doing intercepts. My other answer is -6. And then I just pop them back into my formula, my brackets, and then I have my 2 answers. And I did ask, maybe it will be clearer in the exams. Look at small details, like if they say the values of k, then that might mean that there's more than one value for k, and then you know, okay, I need to do one more, or I need to discard one, or I can keep both. Last question. I want to just show you how to do reverse midpoint. If I give you a diameter and I give you a center, you are able to get one of the outer points then. If let's say B was X and Y and A was -1 and 1, then you can use the fact that this is a radius and a radius. So you can use midpoint. The only problem is I don't think we're used to doing midpoint as given and one of the outers as unknown. So let me show you how I do this. I say my 2 outer points over 2 is equal to my midpoint. And then I can do the same thing for my Y value. Have a look. My midpoint is created from adding my 2 outer points over 2. And then if you solve this, it's pretty easy. Times both sides by 2, -1 plus X. So X is 5. Same here, 6. 1 plus Y, so Y is 5. So then you have your outer point. And then with this, remember I can ask you then whatever, tangents or whatever other question I want after that. Guys, and I think that's a wrap for today. I'm open to any difficult questions that you guys might have. Love to start making videos more often, once a week for now. But please leave a comment, subscribe, and I will continue doing revision with you with A-levels. Thank you. Bye.